Hello students, in the previous video I've shown you how we can solve the ISC 2024 paper. Section A, B and C are already discussed. Now I am taking up section D. Section D starts with question number 19, 5-mark question. An organic compound A having a specific smell forms two compounds B and C by reacting with corn sodium hydroxide. The molecular formula of compound B is C7H8O. Okay, C7H8O, which forms a compound A again on oxidation. Compound C forms benzene on heating with soda lime. It's an aromatic compound. So let's start compound A. Write structures of compound A, B and C, and also write the reactions involved. Okay, let's take up the reaction. That is C6H5CHO. That is compound A. Reaction with NaOH will give C6H5CH2OH plus C6H5COO. So two compounds are formed. So this is compound A, this is B and this is C. Okay. Now compound B, the next part says as formula C7H8O. So that is matching. So we will take up compound B, which forms compound A again on oxidation. So let's see that C6H5CH2OH on oxidation will give alcohol on oxidation gives aldehyde C6H5CHO. So this is B changing to A on oxidation. Okay. Now compound C is reacting. Compound C here is C6H5COONA, sodium benzoate, on reaction with soda lime. Soda lime is sodium hydroxide and quicklime. This reaction requires heat also. So you get this thing will be removed. That is Na2CO3 goes out, and what you have is C6H6, benzene is formed. So we have, now what are the compounds we can write here? Compound A is benzaldehyde, compound B is benzyl alcohol, compound C is sodium benzoate. Sodium benzoate. So A, B and C are asked. So we have solved that. Now let's go to the next part of this question. Part 2 of question number 19. Identify compounds A and B in the following in the reactions given below. C6H6 anhydrous aluminum chloride and methyl chloride. The reaction is happening. So alkylation happens. So it should be compound A should be C6H6CH3, that is toluene. It should be toluene, and undergoes oxidation. B is formed using acidified potassium dichromate. The end product will be C6H, sorry, this is 5 CH3 C6H5 COOH, that is benzoic acid. Identify. So we have identified. Going to the next part. So we have CH3, CHOH and CH3, that is propane 2-ol. Isopropyl on oxidation gives compound A. Compound A, this alcohol on oxidation, it will give a ketone CH3, C double bond O and CH3. So which is otherwise called acetone or propanone. Okay. And next part is, okay, it undergoes reaction with hydroxylamine giving compound B. Compound B is this one, CH3, C double bond NOH, the hydroxylamine CH3. So this will be called acetone oxime. This is compound B. Okay. Reaction with hydroxylamine. Okay, that is done. Question number 20. A coordination compound has a formula COCl3 4NH3. Okay. It precipitates silver ions as AgCl and its molar conductance corresponds to a total of 2 ions. Okay, 2 ions. Based on this information, answer the following questions. Okay, COCl3, 4NH3. So let's write that COCl3, 4NH3. Okay, and give silver chloride precipitate. Now reduce the structural formula of the complex. It corresponds to 2 moles of, it says total of 2 ions. Okay, that means there will be 2 ions. So we can write the formula of the compound. So what will be the formula of the compound? Let's see. So there are 2 ions only. So CONH3 4 times, 4NH3 is there in the question, so 4 times, and there are 2 ions, means there is only 1 ion outside, so that means we have Cl2 inside and 1 Cl outside. So when it dissociates, 1 Cl minus ion is produced and 1 coordinate ion is produced, right? So there are 2 ions, that is what the conduction says. So this is the formula of the compound. Write the IUPAC name of the complex compound. So what will be the complex? Tetraamine. Tetraamine. There are 2 chlorines inside, so dichlorido cobalt. The oxidation state here is 3 plus 3 and minus 2 and 1 minus 3, right? Cobalt 3 chloride. That is the IUPAC name. Draw the geometrical isomers of the complex. What are the geometrical isomers possible? Okay, it's a octahedral complex. So CO, we have NH3, NH3, NH3 and NH3, and the chlorines, the 2 chlorines are 1 here and 1 here. Okay, so this will be positively charged, the other chloride is outside. Now what will be the geometrical isomers? So the other isomer will be, so this has the chlorines placed diagonally opposite, so this will be the trans isomer. Now what will be the cis isomer for this? CO, Cl and 1 chlorine comes here. The ammonia goes here, NH3 and NH3 and NH3. So this will be the plus charge, this will be the cis isomer. Okay, so that is the 2 isomers. Now give a chemical test to show that CONH3 5 times Cl SO4 and CONH3 SO4 Cl are ionization isomers. Okay, here we have the sulfate ion outside, in this we have the chloride ion outside. So we have to show that they are ionization isomers. So what will be the test that we can give? Chemical test. Okay, let's answer this. CONH3 5 times Cl SO4. This can react with barium chloride solution, BaCl2 solution. It will give white PPT. Okay, the other compound is CONH3 5 times SO4 and Cl is outside. Okay, so plus barium chloride solution, there will be no PPT. So in this case barium sulfate will be formed, that is the white PPT. Here barium sulfate cannot be formed, barium chloride is soluble, barium sulfate is insoluble, white PPT comes. So this way you can differentiate. Silver nitrate you cannot use because silver chloride precipitate will come in this case. Here silver sulfate will come. Silver sulfate is also insoluble and forms white PPT. So that does not differentiate. So this is the correct answer. You may find sometimes some people use silver nitrate, but it is not the perfect answer. Going to the next question. Study the diagram given below that represents CuHg electrochemical cell. Okay, copper silver cell, and the answers the questions that follow. The E0 value for copper cell, copper, and for silver is also given. Write the cell reaction for the above. So first thing is to write the cell reaction. Okay. So what will be the cell reaction here? Cu plus 2Ag plus. Now which one is the anode, which one is the cathode? That's what you have to first identify. So it will become Cu plus plus or Cu2 plus and 2Ag. So copper is giving the electrons acting as the anode, and silver is gaining the electron acting as the cathode. So this will be solid, this will be AQ, aqueous. Here this is aqueous, copper ions are produced, and this is solid. Okay. Right, now calculate the standard EMF of the cell. So how do you calculate? E0 cell is equal to E cathode minus E anode. E0 cathode, E0 anode. So what are the values? Values are given here. The value of E0 cathode is 0.799 minus 0.337 is equal to 462 volt. So that is calculated the standard EMF of the cell. Then we can go to the next question. If concentration of Cu2 plus is 0.1 m and E cell is 0.422 volt at 25 degrees, calculate the concentration of Ag plus ions. Okay, so we have the formula. So E cell is equal to E0 cell minus 0.0591 upon N into log of, we have Cu2 plus ion concentration divided by Ag plus ion concentration to the power 2. 2 ions of silver is produced because of that, and therefore we can put the values. So E cell we already know, that is given as 0.422 in the question. It's equal to E0 we have calculated 0.462 minus 0.0591 upon N. 2 electrons are transferred, 2 into log of the concentration of copper is 0.1, this here 0.1 m, divided by silver ion is to be calculated, Ag plus to the power square. Okay, so we can solve this equation using calculator. So Ag plus ions equal to, first you will get Ag square, then take square root. So in one step you can find out from using the calculator. So I'm not doing all the mathematical steps here, I'm just solving here. Coming to be 0.0666 non-terminating 6 moles. So this is the concentration of silver ions. Then calculate delta G for the cell. Okay, delta G is equal to minus NFE. That's equal to, we have minus N is 2 here, minus 2 into F Faraday 96500 into the value of E we calculated. So what is the value? E is given here 0.422, 0.422. So you can use the calculator again and take up the values. Going to be minus 81 joules, that's equal to minus 81.446 kilojoules. This is common or decimal. Okay, so that is calculated. Going to the next question, the B part of this question, that is calculate lambda 0 m for barium chloride and aluminum chloride from the following data. The data is given, so all the values are here, so you can calculate straight away. Lambda 0 for BaCl2 barium chloride is equal to lambda 0 for m for Ba2 plus 2 into, there are 2 chloride ions, lambda 0 value for Cl minus. Okay, that's equal to, it is given here 127.2 plus 2 into 76.3. So use calculator. is coming to be 279.6 Siemens centimeter square per mole. Okay. Now the second one is for aluminum sulfate. So lambda 0 for Al2SO4 whole thrice is equal to, we will take the value for aluminum. 2 into aluminum is 189. There are 2 aluminum ions, okay, plus 3 sulfate ions. The sulfate ion is given 3 into 160. So that is equal to, use calculator again, 858.0 Siemens centimeter square per mole. Okay, so that is done. Going to the choice of this question. A 0.05 m ammonium hydroxide solution offers a resistance of 30.8 ohms to a conductivity cell at 298 K. If the cell constant is 0.343 per centimeter and molar conductance of NH4OH at infinite dilution is 471.4 Siemens centimeter square per mole, calculate the following. The specific conductance. Okay, so how do we calculate? Specific conductance is equal to, that is kappa is equal to 1 upon R into L upon A, that is cell constant, that is equal to 1 upon R, resistance offered is 30.8 ohms, into L upon A is the cell constant given as 0.343. So multiply this, so you will get equal to 0.011136 Siemens centimeter per centimeter, right? So this is the specific conductance. Going to the next part. Okay, this is the next part, calculating the molar conductance. So molar conductance is lambda m is equal to kappa into 1000 upon C concentration. That's equal to what is the value of kappa we have calculated? 0.01136 into 1000 upon 0.05. I think concentration given is here 0.05. So that's equal to, calculate, triple 2.72 Siemens centimeter square per mole, molar conductance. Now the next part is the degree of dissociation. How do you calculate degree of dissociation? That is alpha is equal to, so lambda Cm upon lambda 0 m is equal to, this is molar conductivity, lambda Cm, 222.72 we have just calculated, divided by the molar conductivity at infinite dilution is given 471.4, 471.1. Okay, 1 4 it is 0.4 is equal to, yes, let us calculate. .472, or we can say 47.2%. Percentage we will multiply by 100% dissociated. Okay, now going to the next question, the B part. In the diagram of the electrolytic cell given below, A, B and C are connected in series having electrolytes of zinc sulfate, silver nitrate and copper sulfate respectively. A steady current of 1.5 amperes was passed until 1.45 grams of silver was deposited at the cathode of cell B. Atomic mass of given. Okay, let's see this. How long did the current flow? Now there are 3 cells here. So what you can do, you can calculate how long did the current flow. That is the first part. Okay. Here we have the given weight of silver, Ag, the weight given. What is the weight given? Okay, 1.45 grams. And what is the current? 1.5 amperes. 1.5 amperes. So let's write the formula. W is equal to ZIT, or you can say W is equal to E upon 96500 into I into T. I is current. Okay, so we can put the values. That is 1.45 is the weight, W is equal to 108. The equivalent silver it is, no? Silver is equivalent weight, 108 divided by 1 into 96500 into 1.5 is the current into time. We need time here from here. Okay, so what is T? So T is equal to, you can change the subject of them. I am just solving straight away in calculator instead of thinking. 863.73 seconds. Or you want to convert it into minute, you can do. So it will come, can divide by 60, you will get 14.39 minutes. Okay, right. So that is about the how long did the current flow. Next part is what weight of copper and zinc are deposited at the cathode. So the formula we can use, weight of copper upon weight of silver is equal to equivalent weight of copper upon equivalent weight of silver. So that is weight of copper upon weight of silver is given as 1.45 grams in the question, divided by, here you have the equivalent weight of copper is 63.5 is the atomic weight given here. Yes, divided by 2, it produces 2 electrons, divided by the equivalent weight of silver, that is 108 upon 1. Okay, so from here we can bring this to the other side. You will get weight of copper. So weight of copper is equal to, calculate, (0.426 grams is coming. Now the next is weight of copper is in. Weight of zinc also is required. So for that we will use the same formula again. Weight of zinc upon weight of silver, because that is the weight of silver is given in the question. So we are using that again. So E, equivalent weight of zinc upon E of silver. Okay, so that is weight of zinc is equal to, equivalent weight of zinc is 65.3 upon 2 divided by 108 upon 1 into this, I am taking this side, into 1.45. So that is equal to 0.438 grams. Okay, so that's all in this paper. We solved all the questions, section D also. So you can keep practicing these questions. That will help you face your chemistry examination in ISC, okay, which is coming. All the best to you children.